Welcome back to Lesson 30, where we study applications of integrals. Uh, Especially, we are going to learn how to find the volume of objects that are generated by rotating through an axis. So there are 11 problems. Let's go to start with the first one. The first method that we are going to use to calculate the volume uh, inside the, the, the rotating curve, we have a rotating curve. We have this curve, y of x. If we rotate y of x through the x-axis, we generate an object who has a volume, and the volume that is inside the object is being obtained by a method that is named the this method. So the this method say, imagine that you fill this region by infinitesimal disk. Every disk will have a radius, different radius. If you have the disk here, they will have that different radius that if you have it here, of course, and it will have a volume. The volume of a small cylinder, a small disk, is the area of the base pi r squared by the height. In this case, the height is delta x. The radius is changing with x. As you go through the x-axis, the radius is becoming, in this example, the radius is becoming from very big to very small to 0 here. So the idea is to split the object into a very small tiny disk, very small tiny cylinders, and to add the volume of each cylinder, making the integral. So this is a nice applications of integrals to find the volumes. So the small volume will be pi r squared, the radius pi r squared by ddx, by the small ddx, by the small height. In this case, the radius is f of x. The radius is f of x. Okay, f of x. This is the radius of each disk. And the total volume, this is the small volume, and the total volume is the sum of all the smallest volume. And the sum is the integral of pi fx squared ddx. Okay, so this is this method, and if you go to your textbook, you will find what it say by this method, and it say that this method about the x-axis say, let's have be a continuous function, let's be f of x positive. Why f of x should be positive? Well, volumes are something that are positive. So the f of x have to be positive, and the dx have to be also positive. You are moving to the right. In this way, you are summing positive numbers. So the total volume will be, of course, positive. None of the terms will be negative. All of them will be positive. If the region R bounded by the graph f and the x-axis, this region, this is the region R, and the region R exists between the curve x equals 0, this curve, and x equal 2. X equal 2 is the vertical line that passes through x equal 2, and is revolved around the x-axis. When you revolve the functions around the x-axis, you will obtain a figure that is something like this. Let me erase here. Let me So it's something like this. If you revolve through the x-axis. So now you will consider a small disc here that we fill, that it will fill the volume inside. And for each small disc, the small volume will be pi r squared. R squared will be the radius. I draw this like this. Let me draw correctly. Let me draw correctly. So it will be more like this. Let me see. It will draw more symmetrical. So the radius, it will be like this. The radius is this one. The radius is from here to here. This is the radius. The radius is the value of the function. So it's pi f of x squared by d dx. This is the small volume that exists at the position x. This is the volume. So I will add it. The volume will be the added of all the small disk. So it will be the integral from x equal a to x equal b of pi f of x squared d dx. And this is what it say this method about the x-axis. And this method about the y-axis, this method about the y-axis will say like this. Let's say that you have the function. Let's say this function. You need to imagine this thing. This is the function y of x. So you revolve the function through the y-axis. This is the y-axis. When you revolve the function through the y-axis, you will obtain something that is like this. So you will fill in with a small disk. And every disk will have a volume. So the volume of this disk is pi r squared by the height. So the small volume here will be pi. Now r squared is this distance, and is this distance square. And this distance is not y of x, is x of y, is the distance that exists at the point y, at the height y. So x of y squared by the height. The height is this distance, so it's d dy. And you need to walk in the direction where the x of y is positive and d dy is positive. So you need to walk in this direction. You need to sum in this direction. So the volume will be the integral of pi x squared of y by d dy. So it will be an equation related with y. X of y will be maybe y squared or y cubed, whatever. From y equal, let's say, c to y equal d, where c will be the horizontal line here, and v will be the horizontal line y equal d. So you fill the volume, and you find the volume by this expression. So let's go now to practice this expression. Well, in your textbook you can find figures like this that I cannot do it so well. For example, this figure, when you revolve through the x-axis, the object that you will obtain will be something like this. It's like a cone, it's a cone, but with this line curve. It's not a cone. A cone is a rectilinear line here. It's not exactly a cone. The challenge here is to find the volume that is inside by imagining that this volume is filling with infinity amount of a small disk, infinitesimal size of volume of this, and the sum of all the volume of each disk, the sum is the total volume inside the figure. Please put the video at speed 2 for about 1 minute. I'll solve the problem after 1 minute.
¿Dónde van a cenar?
Okay, now that we have written the steps that we are going to do always to imagine the process, because the important thing in this problem is the setup of the problem. If we set up the problem to do the integral, the calculation of the integral is not so important. What is important is the setup. So the steps that I have writing are like this. Step 1, say revolve through the x-axis and find the object. Find the object in your mind, of course. Step 2, fill the object with a small disk. Imagine a small disk that run through the x-axis. They are running. The center of the disk is touching the x-axis, and you are moving every disk through the x-axis, and you are summing the volume of each disk. Write the step 3, write an expression for the volume of one element of disk. So the expression for one element of this will be pi r squared by the height. In this case will be pi, but the radius will be f of x squared multiplied by the height. The height is in the direction of the x-axis, so it will be d dx. So the what you need to have in mind is this figure. No, this is the function. This is the function. This is the radius r, that is the function. This is the disk, and you are feeling the object when you revolve. You are feeling, after revolving, you are feeling the volume with a small disk. And each disk have a small volume. And the small volume ddv is pi f of x squared d dx. In our case, f of x is minus x plus 1. So what is the total volume? The total volume is the sum of all the small volume, the sum when x vary from 0 to a certain point, that in this case is x equal 1. So the object exists between x equals 0 and x equal 1. So the sum of all the small volume would be the integral from x equals 0 to x equals 1 of pi minus x plus 1 squared d dx. You do the integral, you find a number, and this is the volume. Okay, now you may ask, can I prove that the volume of a cone is 1/3 pi r squared by h? This is the cone. This is the radius r. This is the biggest radius. Can I prove that the formula for the volume doing this method, can I prove that the formula for the volume of a cone is this one, 1/3 pi r squared by h? Let's go to do it. So what you will do, you will take the figure and you will divide the figure into a small disk. Where are these small disks? Is the disk that will fill the cone. And you will make the volume of one of these disk elements, and later on you will make the sum of all these elements. So let's go to do it for the case of a cone. The cone exists by revolving the line, this line that connects the point 0r with the point h0. The cone exists by revolving this line. Who is this line? This line is a rectilinear line, and it's the line that passes through the point 0r and h0. If you find this line, you will obtain that the line can be expressed like y equal r minus r divided by h by x. When x equals 0, y equal r. When x equal h, y equals 0. When x equals h, y equals 0. So this is the rectilinear line, and here is the calculation. You know how to do it. So the small volume of a small disk that exists here will be pi r squared by h. But who is r? R is the radius that exists at the distance x. So r is this radius, but this radius is the value of this function. So it will be pi by the value of this function square by d dx. And what will be the total volume? The total volume will be the sum of all the smallest volumes, the sum of all of them. So the volume, the total volume, will be the integral from x equals 0 to x equal h, because you move from x equals 0 to x equal h, x equals 0 to x equal h, so you will obtain the volume of the cone from x equals 0 of pi by y squared by d dx. Now if you if you work a little bit with this, it's not difficult to arrive to the to this equation. Is the integral is very easy. You know how to do it, this integral. You make a little bit of algebra, and if you make a little bit of algebra, you will obtain that the volume is 1/3 pi r squared by h. Doing the method, this method, you can obtain the volume of a cone. We will do this method for a sphere to find the volume of a sphere. Okay, let's go to the next problem. Okay, this problem is also an application of this method. When you rotate through the x-axis, it's say like this. Suppose that you have the function y of x equal 4 minus x squared. So you have it on the first quadrant, the function. Indeed, the function will do like this here. It's a parabola, but you only want to generate an object taking into account only this part of the graph. So the function when x equals 0, y equals 4, when y equals 0, x equals 2. So this is the function. Now you have to imagine the generation of the function when you revolve the functions around the x-axis. So the function will be like this, something like this. Let's go to put it in another color. Now you will fill the space of this function by disk. So this is one disk. The biggest one is at the beginning, at x equals 0, and the smallest one is when I approach to x equals 2, and in x equals 2, the volume of the disk will be 0. So what is the setup of the problem? Write an expression for the volume of a small disk. The small volume of a small disk is pi r squared by the h. But what is indeed this? Is pi, the radius of the disk is this radius, is the value of the function. So it's r of x, is pi r of x, pi r of x squared by the h. But who is r squared? Is y of y is 4 minus x squared squared. By the height is moving in the x direction, ddx by ddx. And now find the total volume. The total volume is obtained by integrating this, by summing all the small disks. It will be the sum will be between x equals 0 and x equal to of what? Of ddv. Who is ddv? Pi 4 minus x squared ddx. And whatever it gives you a number, and the number is the volume, represent the volume that exists on this figure, inside this figure. So you imagine that that the disk, it goes to be very big at the beginning, very volume disk, okay? So this is, so at the beginning it's a very big disk, and as you approach to here, the adding this, you are adding a smallest volume disk, okay? Something like this. Okay, let's go to the next problem. So for this problem, we have to find the volume generated by revolving the region bounded by the graph of the equation y equal 2 and y equal 4 minus x squared divided by 4 about the x-axis. So what is the region that we want to revolve? Let's go to that. Y equal 2 is the graph, is the horizontal line, y equal 2. This is y equal 2. And the graph of y equal 4 minus x squared divided by 4 is a parabola inverted, where when x equals 0, y equals 4. So this is the 4, this is 2, this is 2, this is 4. And the parabola will do like this, The parabola will cross this point, so y equals 0 means, because y of x equal 4 minus x squared divided by 4, it means y equals 0 means that the x is 4 equal x squared divided by 4, so x squared equals 16, so x equal plus minus square root of 16 or 4. Here is the 4, here is the 4, but the interesting point is this point. When they cross, when they intersect the graph of y equal 4 minus x squared divided by 4 with the line y equal to, well, they intersect when they have the same y, or they intersect when 4 minus x squared divided by 4 equal to, or in other words, they intersect when 4 minus 2, 2 equal x squared plus 4, or in other words, when x squared equal 8, or in other words, when x equal plus minus the square root of 8, or plus minus 8 is 4 by 2, square root of 4 by 2, and a square root of 4 is 2, so it's 2 square root of 2, so plus minus. So when the x is plus 2 square root of 2, so this point is the point 2 square root of 2. And this other point is the point minus 2 square root of 2. Now we can read now again the problem. It says, find the volume of the solid generated by revolving the region bounded by the graph of the equation y equal 2, and about the x-axis. About the x-axis. The region bounded by the two graphs is this region. And I have to revolve through this x-axis. When I revolve, I will obtain a figure that have a volume. And the problem is asking me, what is the volume of this figure? So how I will do it? Well, I will do it in the following way. If I revolve this function through the x-axis between minus 2 square root of 2 and 2 square root of 2, I will obtain a big volume. The volume will be pi by the radius squared, that is the value of the function, by ddx. So the volume of the parabola will be pi by the function squared by ddx. And the total volume will be the sum of all these disks, and it will be the integral from x equal minus 2 square root of 2 to x equal 2 square root of 2. And the graph from y equal 2, when I rotate, I generate a cylinder. So the volume of the cylinder is pi r squared by the height. The height is from minus 2 square root of 2 to 2 square root of 2, or 4 square root of 2, and the radius is 2, and the area is pi by 2 square, so it would be 4 pi multiplied by 4 square root of 2. Or, let's go to do it, the area will be, the area of the cylinder, that will be pi 4 squared ddx. The area of this cylinder is pi 4. So the area that generates the line y equal 2 will be, the volume that generates the line y equal 2 will be pi, the integral of pi 4 squared by d dx, so it will be pi 2 squared 4, 2 square root of 2 minus 2 square root of 2, so the volume that will generate will be pi by 4 multiplied by 4 square root of 2, so it will be pi 16 square root of 2. And if you don't want to do the integral, you may say that the area is, this is the radius, is the volume of the cylinder will be pi by 2 square by this side, that it will be the height, it will be 4 square root of 2 and should be the same. 4 by 4, 16, yeah, is the same. So what is the volume that is between the two figures? The volume that is between the two figures is the integral, is the subtraction of the two volumes. This is the volume that is the washer method, is the volume that stay here when I rotate. When I rotate respect to the x-axis, it will appear a volume, so the volume will be the volume for the external radius minus the volume from the internal radius. The external radius is this one, this one is the external radius, and the internal radius is this one. So, what is the volume? This is the small volume, and the total volume is the integral of this from x equal minus square root of 2, 2 square root of 2 to x equal plus 2 square root of 2. I might have found it because it's the subtraction, is the volume V1 minus the volume V2. Okay? And the problem is done. Problem 4 says find the volume of the solid generated by revolving the region in the first quadrant of the graph, bounded by the graph. Y equal x squared is this graph. Y equal 4 is the horizontal line. And x equal 0 is the y-axis. And you revolve now about the y-axis. The y-axis. If you revolve the region bounded by this graph, the region bounded is this region. So you revolve the region through the y-axis, and when you revolve, you will obtain this volume. So now you can apply this method to find the volume. So what is the small volume of a disk here? The small volume of a disk is pi r squared by the height. What is pi? Is pi. R squared is the radius squared, this radius. The radius squared is x of I. Squared is the radius of r of y. If you prefer, I will put r of y, the radius that exists at the height y. R of y squared by the h. The h is this h, dy. So the small volume will be pi r squared, but y is equal x squared. So this is y of x, but I want x of y. So x equal plus square root of y. In this case, it's plus square root of y because this is the graph. This is the graph. This is looking to the right, so the x is positive. The x is positive. So x equal plus square root of y, square root of y squared by dy. So we need to make the volume, we need to find the volume. So the volume will be the integral. The integral dy will go from 0 to 4. So this is the dy. from y equals 0 to y equals 4. Of what? Pi I d dy. What would be this? It would be pi I squared divided by 2. What will be this between 0 and 4? Will be pi 4 squared, which is 16 divided by 2, or 8 pi. Now, this problem says find the volume of the solid generated by revolving to the region in the first quadrant bounded by the graph of the equation y equal square root of 16 minus x squared. This looks like a circle, so this is in the first quadrant. This is the circle. The radius is 4 and 4, and this is the graph of y equal square root of 16 minus x squared, or y squared plus x squared equals 16. Of x of y that I will need it will be a square root of 16 minus y squared, and this is the x positive. So if I rotate through the y-axis, the figure that I will find is this one. Now I will fill the regions with disk. The disk that I will find is a disk of radius x, and the height is d dy. So the small volume of the disk is pi, the radius squared by h, or in other words, pi by the radius that depends on y. The radius depends where you are on the y-axis by h. Or in other words, pi by the radius that depends on y is the x. This is the radius, the x of y. Pi is square root of 16 minus y squared. And the height of the small disk is d dy. So what is the volume? The volume is the sum from y equals 0 to y equals 4. You arrive to here, and you are summing disk, many disks, infinity number of disks of pi square root of 16 minus y squared d dy. But is pi, r squared. So this is a square. Now, yes. Now the volume will be the integral from y equals 0 to y equals 4 of pi that multiplies 16 minus y squared d dy. And this volume can be, and this integral can be done very easily, and you can obtain the result. Let's go to do it. It will be pi that multiplies 16y minus y cubed divided by 3, evaluated between 0 is a nice point to evaluation, and 4. So it will be pi by 16 multiplied by 4 minus y cubed, 4 cubed divided by 3. And maybe this method allows you to find the volume of a sphere of radius r. Let's go to do it. So now we face a more general problem. We have this curve, the sphere. So we revolve through the y-axis. The radius of the sphere is r. The equation of the equation of a circle is x squared plus y squared equal r squared. When I revolve through the y-axis, I generate half of the sphere, the volume of half of the sphere. Now the volume you imagine a small disk, the height of the disk is d dy, the radius of the width is dx, is the value of x, and the small volume that is here is pi by the radius squared by the h, or in other words, is pi the x of y squared by the height that is d dy. The height is d dy. So this, from the equation of the circumference, the x of y, x squared will be r squared minus y squared. So the x will be a square root, but the x squared will be again r squared minus y squared. So the small volume, the expression for the small volume will be pi r squared minus y squared d dy. And now we need to integrate to find the total volume. The total volume is the integral when y start at 0 and end in y equal r. Y start here at 0, the horizontal line start at 0, and you go up, and you go to the final y, that is the radius r of the sphere, of the circle. Okay, of pi r squared minus y squared d dy. Let's go to do it. So doing the integral will be pi r squared by y minus y cubed divided by 3. Evaluate between 0 and r. So this is the volume. So the volume will be pi r squared multiplied by r minus r cubed divided by 3. And this is pi r cubed minus 1/3 of pi r cubed, or the volume is 2 pi r cubed divided by 3. But this is half of the volume, so the total volume of a sphere will be 4 pi r cubed divided by 3. Conclusion, I have found that the volume of a sphere using this method is 4 pi r cubed divided by 3. Okay, let's go to do problem 6. Say, find the volume of a solid generated by revolving the region in the first quadrant, bounded by the curves. The curve is y equal x to the 2/3. Square root of x do like this, so y equal x to the 2/3, that is smaller than 1. 2/3 is smaller than 1, should be something similar. Y equal 1 is the horizontal line, which is always y equal 1. So it will be this line. And x equals 0 is the y-axis. X equals 0. And the region that is here is this one. The region bounded, and I rotate it through the y-axis. So if I rotate it through the y-axis, I can see the volume, I can see the region, I can see the radius of the disk. So it's a find the volume. So let's go to find a small volume first. The small volume will be pi by the radius squared by the height. So by the small height. So the small volume will be pi the radius squared is x of y squared. X of y squared by the, if I rotate it, I will have the d dy by the half, by d dy. So the small volume d dv will be pi by x of y. But I know y of x, so I have to obtain, I know y of x is x to the 2/3, and I want to find x of y. So I will raise this to 3/2, and this one to 3/2, and we'll obtain y 3/2 equal x. So x of y is y 3/2. So y 3/2, that is x of y, by d dy. And now I will integrate d dv, the integral. V will be the integral of all the d dv's, and it will be the integral of d dv. It will be the integral of pi y 3/2 d dy from y equals 0 to y equal 1. So you integrate from y equals 0 to y equal 1, so it will be pi y 3/2 plus 1 is 5/2. Divide by 5/2, which is 2/5. Between 0 and 1, this is 1, so it should be 2/5 of pi. This is the volume. But I made a mistake, because x of y is square, so I didn't put it a square. So let's go to correct it. It's a square. X of y is squared, so now the integral will be, and this result is wrong. I'm sorry, this result is wrong. It will be pi by y cubed d dy, or pi y4 divided by 4, or pi divided by 4, if you evaluate between 0 and 1. And this now is the correct result. So this problem says find the volume of the solid generated by revolving the region bounded by the curves y equal 5 minus x is the rectilinear line that has slope minus 1 when x equals 0, y equals 5, when y equals 0, x equals 5, this point. So this is the rectilinear line. The other line is the horizontal line y equals 0, this one, the x-axis. Also the other line is y equals 4, x equals 0. X equals 0 is the y-axis, x equals 0, and the line x equals 5 is this one. And you revolve, no, the line x equals 5 is this one, and you are revolving the figure about x equals 5. So x equals 5 is the axis of rotation of the whole figure. And you are going to find the area of what figure? Well, I suppose it's this figure, this one that we are going to find the area. This one, this triangle. This is bounded by the rectilinear line, bounded by x equals 0. Wow, what is the x equals 0? Bounded by y equals 0. Okay, this line, by y equals 0. By x equals 0. Okay, this line, so I'm in the first quadrant. The rectilinear line, okay, this line. So it's this part, and why? But so it's this part what we want to produce the is this part. Okay, this part is the part that we are going to rotate through the axis x equal 5. So I have the x equal 5 here, the line x equal 5. I have this picture to rotate, this one. This is 5. What I'm going to rotate is between y equals 4 or this picture. So this is 4. So I'm going to rotate through the axis x equals 5. So what is the radius? We are going to find the exterior radius minus the volume of the figure of the exterior radius minus the volume of the figure of the interior radius. So the exterior radius is this one. And the exterior radius is 5. And the interior radius is this one. So I will find the volume for the exterior radius, and I subtract to the volume of the interior radius, and I will integrate between y equals 0 and y equals 4, and I will find this volume, this one. Let's go to do it. So the volume V1, the exterior volume, V exterior is when the line x equals 0 is rotated through the line x equals 5. This produces a cylinder. And I can find the cylinder easily, the volume of the cylinder, but maybe we do it using integral. So it will be the integral from y equals 0 to y equals 4 of pi by the radius square, but the radius square is 5. 5 is the radius for this x equals 0. The whole radius would generate a cylinder. 5 squared by the height. The height is d dy. And this will be, if you do the integration, will be 25 pi multiplied by 4 or 100 pi. This is the exterior volume. And the interior volume is the volume when the radius is changing, like this, is changing. And what is the V interior? V interior is pi, let's go to find ddv interior. The ddv interior, this ddv of a small unit. ddv is pi. Now the radius, this is the 5 meter. The radius is this one. This one is the radius. And I have to put the radius square. How I will write this expression, the radius? The radius is r of y. Wow. Well, I know what is that. This is 5. And this is the distance from the point y to the rectilinear line. So the curve is y equal 5 minus 5x. Let me see. 5 minus x. 5 minus x. So x of y, so x of y will be 5 5 minus y. And this equation is correct. When y equals 0, x equals 5. So when y equals 0, x equals 5. When y equals 5, here, x equals 0 is this point. And when y equals 4, x equals 1. This is 1. Okay, this equation is correct. Now, the interior volume, the volume that is being generated by revolving the line, this line through the axis x equals 5, it would be, the interior volume would be pi by the radius square. But what will be the radius square? The interior radius, the interior radius will be this side, this amount of length, and this amount of length is everything 5 minus x of y. 5 minus x of y is this radius. Okay. 5 minus x of y, or the interior radius is 5 minus 5 minus y, or the interior radius is y. Okay, so the interior volume, the volume interior that generate this figure when you rotate through the x equals 5 axis, it would be the integral from y equals 0 to y equals 4 of pi, the radius, which is y square, dy. And you are summing the interior volume. So it would be pi I cubed divided by 3, or in other words, pi 4 cubed divided by 3. So the volume that remains, this volume, is when you rotate through the axis x equals 5, is the volume of the cylinder when you rotate this axis through the axis x equals 5. So it will be, the total volume will be the exterior volume when the radius is the exterior, when the radius is 5, minus the interior volume. So it will be 100 pi minus 4 by 4 is 16. 16 multiplied by 3 is divided by 16. 4 by 4 multiplied by 4. Well, whatever it is, it would be, let me do it, 100 pi minus 16 by 4. 6 by 4 is 24. 64 pi divided by 3. Okay, this is the result. Problem 9 say use this method to verify that the volume of a sphere is 4/3 pi r cubed. So I think we did it before, and we did it using this method, but in the y direction. Let's go to do it in the x direction. So this is the circumference, x squared plus y squared. This is the circumference, x squared plus y squared equal r squared. We are going to do it in the x direction. Okay, so we rotate. Let's go to erase this. We don't need this part. So this part have a radius, and the radius is the y. So the y of x is r squared minus x squared square root. So if I rotate through the x-axis, I will generate a disc like this one that will have a radius y. And the small volume of this disk will be pi r squared by the height. So the small volume will be pi, now r squared is y of x squared. So y of x is squared by the height. The height you advance in this direction. So you create a small disk like this one by ddx. And now, when you revolve through the x-axis, the figure that you will obtain will be half of the semisphere. So the volume will be the integral from x equals 0 to x equal r. You are moving the disk from x equals 0 to x equal r, and you're finding the small volume of each disk. And the small volume of each disk is pi y of x squared, r squared minus x squared by ddx. So I need to do this integral, and to prove that the volume is 4/3 pi r cubed. So it will be pi r squared by x. If you want, I can put r0 is a number, is the radius, it's not a variable. Pi r0 squared by x minus x cubed divided by 3. And everything is evaluated between x equals 0 and x equal r, little r. And I cannot forget that this is half of the volume. At the end, I have to multiply by 2. So if I have to evaluate this, will be pi between r0, between 0 and r0, r0 squared multiplied by r0 minus r0 cubed divided by 3. So I have pi r0 cubed minus r0 cubed divided by 3. Or I have 3 divided by 3 pi r0 squared, or 2 pi r0 cubed divided by 3. Because this volume is half of the volume of the sphere, the volume of the sphere is 4 times, is 2 times this, is 4 pi r0 cubed divided by 3, and the problem is solved. Okay, problem number 10 says a sphere of radius r is cut by a plane h. The plane h less than r, less than the radius, is the plane, is this plane, is the plane that cut the sphere at the height h equal r, at the height h. So you have a volume here, and the problem is asking you, what is the volume here? If you cut a sphere, what is the volume? Well, you will have the circle of the sphere, and you will rotate this circle through the y-axis, you rotate, you generate a figure. So this is the figure, and you will use this method to find what is the area, what is the volume inside this region. So what is the radius? The radius is the x. And what is the x? Well, because x squared plus y squared is r0 squared, the x at the position y is square root of r0 squared minus y squared. So the small volume that I can put here of a disk that I can put here have the dimension, the pi, the radius square, x squared, by the height dy. So I need to integrate from y equal h, from y equal h to y equal r0. So let's go to integrate. So it's the integral from y equal h to y equal r0 of this element of volume, ddv. And the integral will be, well, this is just to work a little bit, and the integral will be, if you do it, the integral will be just pi r0 square, pi r0 squared multiplied by y minus pi y cubed divided by 3, evaluate between y equal h and y equal r0. So if you evaluate this, it will be pi r0 by r0, r0 cubed minus pi r0 cubed divided by 3 minus, when y equal h, this part. Whatever it is, we can check that when h equals 0, so the plane is in the equator, the volume has to be half of the volume of the sphere. So when h equals 0, this is 0, this is 0, and the volume will be this minus this, which is 2/3. Is half of the volume of the sphere. So this equation is correct and is fine. Okay, good luck. Describe the volume represented by the definite integral pi by the integral from y equal to y equal 4 of y square dy. So this is pi by, this is a small volume, will be the radius r that exists at the point y square by the height. The height will be dy. So this is the small volume, is the radius that exists at the point y, this point. So the radius is this, x of y. X of y equal y squared. So this is the volume generated by summing disk where x of y equal y squared. And x of y equal y squared, this is the 0, this is the y, this is the x. When x equals 0, y squared is 0. When y equal 1, x of y is equal 1. When y equal 2, x of y equal 4. When y equal 3 is 9. When x equal 4 is 16, the radius. So the figure that we are talking is this figure that if you revolve through the y-axis, it will generate disk like this, and you are summing all the disk. When you revolve the function x of y equal y squared through the y-axis, you will obtain a figure, and the volume will be the integral from y equal 2, so it's this integral on this interval from y equal 2 to y equal 4. So it's this volume. It's the volume that is generated here. From y equal 2 to y equal 4, y equal 4 of y4 dy. Okay, that's all. Good luck.